So moving on to distribution data. Distribution data, we'll sort of try to collect for our own particular target species. But when we're moving to phylogenies, that implies that we need multiple species distribution data. Okay? And then it becomes more difficult for us to personally go and collect that information. Therefore, we need to try to find secondary sources of information. So predominantly we may look to museum catalogues, okay, or the literature to try to find distribution data. Particularly when we rely on museum catalogue information or historical records, we need to keep in mind that there are issues with the geographic position of these data. And we need to keep in mind that there's a difference between accuracy and precision. And I don't know how to say this in Spanish, but maybe it's technical.
Precisión y
exactitud.
Yeah, okay, exactly. So that here we've got like 4 examples. The first example, the red point is the reality. Okay. Now, when we have a GPS, depending on the set strength of the signal, we may be, spot on, or we may be some meters out. Okay. For historical records, maybe they didn't use a GPS. Maybe they just looked on a map and then tried to position it. Okay. So that sometimes we have geographic error. Okay. So the size of the black circles represents the error associated with the point. Okay. So here, this data says that we're really sure that it's exactly here, but it's wrong. So this record has exactitude, but not precision. Okay, here we have a big margin of error, okay, but it's still wrong. Here we are geographically located in the right place, but the record has a margin of error around it. And this is the best case where we have our data is exactly in the right place and we have a very narrow margin of error. We have to be careful when we look at coordinate data that we collect from museum records, okay? Particularly in terms of the decimal place precision. Yeah? When we read that we have 25 degrees west and it says 25.00, we cannot assume that this means 25.00 whether 0.00 is, correct. This is really at the level of a degree and not at the level of a fraction of a degree. Okay. So we sort of get used to, we look at those numbers and we see that this record is correct to 2 decimal places. And we need to then understand that this is a reflection of the accuracy of this data, and we cannot assume that because it's 25.25 that we can say this is exactly at this point on the map. Okay? It's accurate to maybe 1/4 of a degree if all of our records have 0.0, 0.25, 0.5, 0.75. Okay? So we need to understand how accurate our coordinates are and what error is associated with them. We should be clear that we should be careful of false precision in our data. Now, this comes from a study on assessing the geographic data quality of records from the Global Biodiversity Information Facility. Are we aware of GBIF? This is a sort of consortium that is a data portal to many, many different museum catalogues. what we did is we had a very good database for legumes called ILDIS. And we used the names to collect all of the records from GBIF that have geographic locations for legumes. So this is, as of 2007, all of the global distribution of legumes according to GBIF. And when I look at this, I see massive, great patches, and I think, are there no legumes in all of Russia? That's not right. Okay? We need to understand that there is geographic bias in the collections that we look at, and because when we look through museum catalogues or the literature, if we do not find records in certain places, that does not mean that they're not there. It means maybe that people haven't been collecting there, or that that data is not available in the places that we are looking. So it's important that the first step of your data gathering process is to search and search and search again for as much distribution data as possible. The more data we have, the more confidence we have in our models. Now, it turns out, as an example, that the reason that there's no, Russian data, or at least at this time, was that they were not contributing to the GBIF portal. So, if we want Russian data, we have to look somewhere else apart from the museum, this museum portal. Okay. And this is the case for many other countries. So there is not a one-stop shop that's going to give us all of our data. Okay, the more we put in terms of time and effort into looking for distribution data, the better our data set will be. Okay, just a few more points on when we collect data that other people have processed, okay, museum catalogue data. There are many common errors associated with distribution data, okay, and here's some examples. Here, this is all of the records that we collected for legumes. Legumes are terrestrial plants. These are all the records that came out in the sea. Okay, and this is typographic errors when people, accidentally type in the wrong number when they're looking through the thing. Okay, and we get records that are just in completely the wrong place. Obviously, we can apply a filter to these records to help identify. What you often see is, especially if you've got a coastal species, you often find you'll get records that are, because of the geographic resolution issue, that what was collected somewhere near the coast, the coordinates are in the sea. Okay, and we need to look out for these records. Okay, perhaps if we know this data, we can make some adjustments to say, okay, that was collected at the coast, and I can adjust these records. But we need to be confident about those records. But this is very common that you find sort of coast-hugging errors. Okay. I don't know what these are. Oh, okay. This is using a different validation technique where, if we're looking at herbarium labels, often on the herbarium label, or the collection record, I always talk about plants because that's what I was looking at. So when I say herbarium records, it could be museum specimens as well. People will write down physically, I collected this in Xalapa, and then they'll put the coordinates in. So you can validate the coordinates against the description of where it was written. Okay. If you've got, this was done at, say, a country level or a state level, where the country or the state was written down, and we can look at on our GIS to say, where is this coordinate? It's in Mexico. Where did the label say? It said England. So we have a conflict, and that tells us there's something wrong with our data. We need to look at it, we exclude it, or we find out what's wrong with it, and then we fix it. Okay? Following on from that, for the eldest data set, we had expert opinion on where this particular species should be found in terms of country level. This is found in Mexico, the United States. Okay? And then we found some records that were maybe in Belize. Okay, so very close to being where the sort of known distribution is. So we need to think about, should we use these records or not? Is it that our expert opinion doesn't have complete coverage? We can use that to help us understand what's good and bad data. And finally, very common error, especially when you've got like hundreds and hundreds of records and you can't look individually at each one, but you'll often find that you get a 0 either in the latitude or the longitude, and you'll end up with like this sort of cross following the 0 line of latitude. And this is important, especially if you're looking at something near the equator, because you can misinterpret a null value as a 0 value, and then you put the incorrect data on your map. So looking at this study, we had expert opinion from the eldest database in terms of which species were present, so that we knew that, I can't remember the numbers, but for example, say, 1,000 species of legumes were present in Australia. And we could use our GBIF data to say how many of those species were represented for this country. Okay? This is a picture of the geographic bias of our data that says certain countries, Australia, United Kingdom, some European countries, have very many species represented in our museum catalogues. Other countries have very few species represented, so the white is a very low proportion of species present. Okay, so this is a picture of global geographic bias in data collection. Okay, we need to understand that if we're looking at many different countries, these different countries will have different different quality of data sets. And when we're looking at larger scales, we need to understand that collection bias and do what we can to compensate for it. Okay, here's an example where we had different data sources that we tried to combine. For cyclamen, we had some expert opinion, which was essentially somebody drawing a line around an area saying this species is found in this location. We also had independently some collections from people going to collect with GPS data. This is the little light dots here. And so we could combine these data sets together. Well, you notice here that this GPS coordinate is a little bit off. Okay?
That's a blend, right? Cyclamen?
Yes, cyclamen. So it's in the middle of it's in the Black Sea. So this is a geographic resolution error. Okay? But here we had two different kinds of data. One with an expert opinion, where somebody had essentially estimated where the distribution was and drew a line around a map. And here we have some actual collections. Okay? These are two different data sets with different qualities. Potentially we could use both for niche modelling, okay? But we need to understand that these are different data sets and they have different biases. Okay? With the sort of expert opinion, which is just somebody drawing a line on a map, based on their knowledge, you get uniform distributions, okay? Which means that each area is equally represented, whereas when we have collections, we get more of a sort of random pattern. Okay? So again, we need to understand where our data, our distribution data is coming from and which biases that gives us.